Okay, this first part are some notes from sections 2.1 and 2.2. So what I'm going to allow you to do is write these notes down. Of course, you can freeze the screen so that you can write them down. And then what I'm going to do is I'm going to pause and then I'm going to show you some more notes. I have notes for section 2.2 as well. So here's the first part, and then I'll show you the bottom of the page next. So you pause the video if you need to write this stuff down. Definitely want to know this stuff. Okay, here's the second part of the notes there for the first side here, and a little bit about some stuff involving quadratic functions here. You can see the parent graph right here. You can also see that it can be in this form, which they sometimes call general form, but it's based on the definition. You saw the definition of a polynomial function at the very top. And then this, of course, is standard form, or I like to call it vertex form, because you can identify the vertex right away. And based on A, you can tell if it opens upward or opens downward. Same thing here. Based on A, if it opens upward or opens downward. And then you can use the little formula here, x equals the opposite of b over 2a, to find the x value of the vertex, which is not only the x value of the vertex, but the equation x equals the opposite of b over 2a is the axis of symmetry. You remember that the axis of symmetry is the vertical line that kind of cuts through the middle, intersects the vertex. The vertex is that point of intersection of the parabola and the axis of symmetry, and it's usually either at the bottom of the graph if it opens upward, or at the top of the graph if it opens downward. And of course, that's important when you're trying to find maximum values and minimum values, because they occur at the vertex there. Also, to find the x and y intercepts, and I don't know if he's going to ask you to find the x and y intercepts. There's a number of problems where they do ask for the x-intercepts. So to find the x-intercepts, you set y equal to 0, you solve for x. To find the y-intercept, and there will be no more than one y-intercept, you set the x equal to 0 and you solve for y. So if it's in this form, if you set x equal to 0 here, it's going to happen when the y value is c, so it's going to be at 0c, okay, from back here. But if it's in this form, it's not going to be 0k, because that's not necessarily going to be that constant term. You'd have to multiply it all the way out and simplify it and put it into this form, which it's just as easy to plug 0 in for x and then solve for y, because that's your y value there. The domain, remember, for polynomial functions, all real numbers, and that's true for no matter if it's a constant function, a linear function, a quadratic, a cubic, a quartic, whatever kind of polynomial function there is. It's just that you do need to know the parent graph a little bit, because most of your graphs that you're going to do are just transformations of this, but we're going to use a t-chart when it comes to graph as well. So a lot of good information in here. Definitely need to know this stuff. Let me raise it up again so you can get the last of the notes. All right, now the notes for section 2.2, and that's for polynomial functions of higher degree. Polynomial, of course, the graph of a function is what we say is continuous. There aren't any breaks or skips or holes or gaps in it. And the domain, as I mentioned just a minute ago, for quadratics is true for all polynomial functions, and that is that it's all real numbers from negative infinity to infinity. The other thing that's kind of cool about polynomial functions is that you get smooth curves, rounded curves. You're going to have some what they sometimes call turning points, or I don't think that's the expression that the book uses. Now all of a sudden I'm glitching in. No, I think it's turning points, and the turning points kind of help you with the graph if you have to graph something. Now with a parabola, of course, there's only one turning point, and that's at the vertex. But when you have parent graphs of higher power, notice I have y equals x to an even power here, like x squared, x to the fourth, x to the sixth. Notice how they kind of all look the same. The one that's skinnier, that's wider on the outside here, that's y equals x squared. The one in the middle there, it's a little bit more rounded at the end here, and that's y equals x to the fourth. And of course the one that's very much more rounded, that's much skinnier here, that's y equals x to the sixth. You see the similarities when it's y equals x to an even power. When it's y equals x to an odd power, like y equals x to the third, y equals x to the fifth, y equals x to the seventh, I went ahead and numbered them 1, 2, and 3 because these are the graphs 1, 2, and 3 here. Now I know it's kind of tough to tell, but the higher the exponent here, the more flat it, the more the graph flattens out when it gets close to 0, 0, when it gets close to its x-intercept. Okay. All right, so that's a little bit about the graphs. Now we'll do graphs as well, but we'll find zeros and we'll do all that, and we'll of course use, here's the next part of your notes, the leading coefficient test. So if you have y or f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 and so on all the way to your constant term, a sub 0, you use the leading coefficient, that's the coefficient in front of the variable with the highest exponent, and of course the highest exponent, that's called the degree of the polynomial. So the degree of the polynomial will be some kind of a whole number. It'll be it will be either even or odd. If n is even, you can tell a little bit about what the way the graph changes, because if n is even, either the n behavior, remember this has to do with n behavior here. Okay, so what's going to happen here is either your graph is going to the ends are going to go up or the ends are going to fall down. If a sub n, the lead coefficient, is positive, it rises to the right and left, kind of like these curves do. It rises to the right and left. Or if a sub n is negative, just like a parabola that has a negative in front of the x squared, your graph opens downward, so it's going to fall to the right and to the left here. So this is just one way to identify this, and you'll have to memorize this. You're just going to have to memorize it. As well as this part, if the degree of the polynomial is odd, and what happens is one end goes up, one end goes down. If a sub n is greater than 0, it rises to the right, falls to the left. And if a sub n is less than 0, just kind of the opposite, it falls to the right and it rises to the left. Now the zeros of polynomial function, you know, if you have a degree n polynomial function, the most zeros you can have are n, most real zeros. You have to remember here that sometimes the zeros are imaginary, so you might not have, when you actually solve and try to find the zeros, you might have less than n, but you can have at most n. And remember, we count multiplicities if the zeros are repeated. All right, and the function of f has at most n, there's that term, n minus 1 turning points. So if you have a degree 5, you can have at most 4 turning points. You might have less than that, but you can have at most 4 turning points. And you say, well, what's the big deal about turning points? Well, that's where your relative maximum and relative minimums occur at. Okay, kind of the top of the hill or the bottom of the valley. All right, definitely with parabolas. So there's a whole bunch of notes. Now, is that all the notes from that sections 1 and 2? No, but kind of based on the problems, I thought that this was a good start. You should definitely know these and be able to use them when you're working problems. Speaking of working problems, let's try some. Okay, so I made up a practice of 20, I think it's 20 problems. It's going to take a little bit to get through this video. I apologize about that, but at the same time, I want to make sure I try to show you a little bit of everything here. So let me find a pencil. Describe how each graph, or I should say, how the graph of each equation is related to the graph of y equals x squared. Now, we had that just a minute ago. That's this guy right here. That's your parent graph for y equals x squared. I wrote it down somewhere, didn't I? I did not. Shame on me. This is y equals x squared. All right, so how does my graph compare? Well, that means what kind of transformations are going on. Are they shifting it right, left, up, down? Are they stretching it, shrinking it? Are they reflecting it? Okay, when we get parabolas that open downward, stuff like that. So here's 3 examples of quadratic functions. And what's going on? Well, the minus 3. So when a minus 3 is on the end like that, not being subtracted from the x, but being subtracted from the x squared, that means it translates or shifts the graph downward 3 units. So this one has a single transformation, and it's just shifting the graph down 3. Now, if that was a plus 3 on the end, then it would shift it upward 3 units. Now here, there are a couple things going on. There's a 1 being added to the x, and then there's this 2 out in front. Well, the 2 out in front is going to be stretching it vertically because you're multiplying by the 2. But what does the plus 1 do? Now, since it's inside and it's being added or subtracted from the variable x, not from the x squared, this affects the x, it affects it horizontally, this way. But how? You say, well, if it's a plus 1, I bet it goes to the right. Well, it would if it was on the outside here to the x squared. If it was a plus 3, I'd say it would move it up. But even though right seems positive, this has to be in the form x minus the number. So this is like a -1. It actually shifts the graph horizontally to the left 1 unit. And then the 2 stretches the graph. So, and then it also stretches or stretches the graph vertically by a factor of 2. So like if you had the points on the graph from the parent graph, you would just double the y value, so it would stretch it out and make it skinnier looking. All right, over here I've got 3 things going on. Look at my x here. There's a 4 subtracted from it. There's a half times all of this, and then there's a +1 on the end. All right, let's start in the inside. You say, well, what do you start with first? Well, if you plugged in a number for x like 10, wouldn't you subtract first? So that's the first thing I'm going to do. This shifts the graph horizontally 4 units to the right. Guess I didn't have to say horizontally if I said to the right. Then it kind of squishes it or compresses it. It compresses the graph by a factor of 1/2, and then it shifts it vertically up 1 unit. So shifts the graph upward 1 unit. See if I can get all that in there. Can you see all that, I hope? Oh, maybe not. Now you probably can't. Got to keep it in the space on my computer that says to. All right, so that's kind of a little bit about the graph. Now they can do all sorts of things. I mean, if I have a negative in front here, that negative would reflect it in the x-axis. Okay, so you have to be on the lookout in case the number in front's got a negative with there. It would reflect it in the x-axis. Okay, so make sure you look over those. Now, identify the vertex and the intercepts and sketch the graph. Well, this is still in section 2.1. What I want to do is graph some parabolas with you. Now, in the first case, the vertex is a gimme because it's already in standard form, vertex form. My vertex is -1, -4. Kind of the opposite of what it looks like inside, exactly what it looks like outside. Okay. The intercepts I can find by, first off, to find the x-intercepts, I set y, or f of x, equal to 0. So that would give me x plus 1 quantity squared minus 4 is equal to 0. And there you could go ahead and square this out and combine it. This would give me x squared plus 2x plus 1 minus 4 equals 0. That would give me x squared plus 2x minus 3 equals 0. What a pain in the keister this one is. So this would be an x plus 3 and an x minus 1 when I factor it. So I'm going to get x equals, I'm going to skip a step here. I'm going to get -3 and +1. So my x-intercepts are going to be -3, 0, and 1, 0. Don't forget to write intercepts as ordered pairs. To find the y-intercept, let's go back to what this looks like when I multiply it out. You see the -3? This is like y equals. So my y-intercept is 0, -3 when it's already expanded out that way. So now to graph it, I'm going to grab a piece of graph paper here. And let's see if I can get this in here. Now you should use a ruler, but I'm going to go ahead and freehand it and try to be neat. And don't forget to set your scale, 1 and 1 here. So let's see, I have the vertex. And by the way, A is positive here. So A is means it's going to open upward. So I have my vertex at -1, -1, 2, 3, 4. Okay? And I have a couple more points. In fact, I have this point, that's the y-intercept. I have this point and I have this point here. Those are my x-intercepts. That's really enough to kind of get a sketch. But you see how when I went 1 over, I went 1 up. So if I go 1 this way, I go 1 up as well. And then I can make my sketch even more accurate. At least try to anyway. So be neat. Okay, now if all else fails, you make yourself a table. Can you see this? Yep, you can. X and Y. Put the vertex in the middle. The vertex was -1, -4. Go 1 to the right, go 1 to the left. Go 2 to the right, go 2 to the left. Then plug the numbers in. These should match and these should match. Okay, so like as we already know, if you plug 1 in, you're going to get 0. This is going to be 0 and this is going to be 0. Those were my x-intercepts. If you plug 0 in, we got -3. So this is -3 and this is -3. And those are the 5 points that I used anyway. But if I don't have that many points there and I need a sketch, that's the way I'm going to go about to do it. Okay, I'm going to make a t-chart. I'm going to start with the vertex. So it was very convenient that it was in vertex form. Now the next one is not in vertex form because there's no quantity squared. In fact, this is kind of a weird one because there's no x term. This is like 2x squared plus 0x minus 1. The reason I write all that out is because to find the vertex in this case, I'm going to use that opposite of b over 2a thing. So a is 2, b is 0, so this would be the opposite of 0 over 2 times 2, which is 0. So that tells me my vertex is 0 something. If I plug 0 in, f of 0 would be 2 times 0 squared minus 1, which is 0 minus 1, that's -1. So not only is that my vertex, but that's also going to be my x-intercept, which is, or excuse me, my y-intercept, which is kind of nice. To find my x-intercepts, it's kind of a pain. You're going to set the 2x, you're going to set y equal to 0, so you're going to get 2x squared minus 1 equals 0. 2x squared equals 1. X squared divided by 2 is a half. Then I have to take the square root of both sides. That's plus or minus the square root of a half, which is plus or minus the square root of 1 over the square root of 2, which is plus or minus 1 over the square root of 2. And if you rationalize your denominator, and I know you haven't done a lot of that lately, by multiplying top and bottom by the square root of 2, you get plus or minus the square root of 2 over 2. Now the square root of 2 is about 1.4, divided by 2 is about 0.7. But this will give me my x-intercepts. My x-intercepts, I have 2 of them. I have one when it's plus and one when it's minus, so I'm just going to write plus or minus the square root of 2 over 2, 0. I don't know if he'll ask you for anything that messy, but it doesn't hurt to practice it. Okay, so now I'm going to make a sketch, at least best I can. So I bring over some graph paper here. Let's try this side. Here we go. Now I'm going to make a set of axes. Everything's kind of centered around the y, I believe. And let's see. By the way, this opens upward because a is positive 2. My vertex is down here. Set your scale. At 0, -1, let's make a t-chart. So my vertex here is at 0, -1. I go 1 bigger, 1 smaller, 2 bigger, 2 smaller. If I plug 2 in, can you see this all? I hope you can see this all. If I plug 2 back into here, f of 2 is 2 times 2 squared. That'd be 8 minus 1 is 7. So if this is 7, then this is 7. If I plug 1 in, I get 2 times 1 squared, which is 2, minus 1 is 1. So I get 1 and 1. See, the 2 makes it a little bit skinnier than the last one. So I plot these points. I have -1, 1. I have 1, 1. I have 2, 7. 2, 3, 4, 5, 6, 7. And I have -2, 7. You can see it's going to be a skinnier graph. It's certainly going to open up upward. You just have to try to make it look smooth and like a curve. A rounded around the vertex there a little bit. Don't make it look like a point, like it's some kind of absolute value, like a V shape or something. There you go. That's what the graph looks like. All right, now let's try another one. Now if you say I got it, I don't need to see the last 2 examples. That's fine. You can come back to them if you want to. I'm going to go ahead and work them out. All right, this is not in standard form. It's not in vertex form. So A is -1, B is -4, C is 5. A is -1 tells me it's going to open downward. Okay, first one I've graphed that's opening downward. And my vertex I can find by the opposite of B over 2A, which would be the opposite of -4 over 2 times -1. So that's +4 over -2 is -2. So my vertex is -2 something. Now to find the something, I have to be really careful. I got lots of negatives and lots of minus signs and all that. I have to plug -2 in here and find f of -2, which would be the opposite of -2 squared. A lot of students are going to miss that. -4 times -2 plus 5. So let's see, that's negative 2 squared is 4, so this is negative 4, plus 8, plus 5. So what is that? That's 9. So my vertex is negative 2, 9. I'm definitely going to make a t-chart here to get some more points. I know that my vertex is negative 2, 9. I know it opens downward. There was something else I was going to say. Oh, what if they say, what's the axis of symmetry? The axis of symmetry is always a vertical line. It's always equal to x equals whatever the x value of the vertex. It's the same as this. So it's x equals negative 2. That's your axis of symmetry. I don't know if they'll ask for that, but just in case, it's easy. Once you have the vertex, the axis of symmetry is x equals whatever the x value of the vertex is. All right, now to find the intercepts, I got the y-intercept right away because of the way it's expanded and written this way. F is 0, plug 0 in for x, is 5. So my y-intercept is 0, 5. Nice. Now the x-intercept, I'm going to have to set the opposite of x squared minus 4x plus 5 equal to 0. I'm going to probably multiply through by negative 1 because I don't really like the way it's written with a negative in front of the x squared. All the signs change. And then this becomes x plus 5, x minus 1. So I get x equals, I'm running out of space, so I'm just going to write it down here. I get x equals negative 5 and positive 1. So my x-intercepts are negative 5, 0, and 1, 0. Okay, in case they ask for the intercepts. Okay, so to find the x-intercept, you set y equal to 0. That's what I did here. The whole thing here is y. To find the y-intercept, I said x equal to 0. And solve. Okay, now let's make a sketch. Just happen to have another piece of graph paper here. Let's see, negative 2, 9 is my vertex, so it's kind of up there. I'm going to make a little bit longer one there. Alright, let's see, something like this maybe. Here's 1, here's 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9. And my vertex is negative 2, 9. Negative 2, 9. I know it opens downward. And I also have some other points. I have 0, 5. 1, 2, 3, 4, 5. And I have negative 5, 0. And I have 1, 0. So that's actually probably to get a decent curve out of that. I'm just going to go ahead and make the t-chart. I just want you to see this enough times so it sticks in your head. To make the t-chart, 5 points is plenty. 2, 3, 4, and 5. And put your vertex in the middle. So my vertex was negative 2, 9. So go 1 bigger, 1 smaller, 2 bigger, 2 smaller. And then plug in. If I plug in 0, now I've already kind of know what it is because I have 0, 5 sitting right there. But if I plug in 0, do the arithmetic, you see the 5. So if this is 5, this is 5. So there's another point, negative 1, 2, 3, 4, 1, 2, 3, 4, 5. There's another point that'll come in handy. And then if I plug in negative 1, f of negative 1, I'm just running out of space here. Yeah, I better do it over here on the graph paper. F of negative 1 would be the opposite of negative 1 squared minus 4 times negative 1 plus 5. So negative 1 squared is 1. The opposite of that is negative 1 plus 4 plus 5. That's 9. That's 8. So this is an 8 and this is an 8. So that means I have this point and this point as well. I have all sorts of points to come up with this sketch. And it clearly opens downward like we said. Okay, put the little arrows on the ends and there's my graph. Okay, one more here with the graph. And this one's already in standard form. This is in vertex form. My vertex is 2, negative 9. 2 from there. Remember, it's the opposite of what it looks like inside, exactly what it looks like outside. Negative 9 there. A is 1, so it opens upward. Okay, so I'm going to take and find my x-intercepts by setting y. That's this, the f of x equal to 0. So I'd have the quantity x minus 2 quantity squared minus 9 equals 0. This is x squared minus 4x plus 4 minus 9 equals 0. This is x squared minus 4x minus 5 equals 0. So this is x minus 5 times x plus 1 equals 0. So I'm going to get 5 and negative 1. I kind of skipped a step there. So my x-intercepts are 5, 0 and negative 1, 0. If you ask for the intercepts, write them as ordered pairs. And then my y-intercept is when I plug 0 in for x. I'll just go back to here. 0 minus 2 is negative 2. Negative 2 squared is 4. 4 minus 9 is negative 5. So my y-intercept is 0, negative 5. Let's come up with a sketch. Well, here, let's do this. I don't want to waste too much more graph paper here if I can. Yeah, I'm going to have to bring it over just a little bit so you can see it at least. Okay, let's make a set of axes. Now I notice that my vertex is 2, negative 9, so that's down quite a bit. So I'll make this one a little deeper. And x-axis up here somewhere. So let's see, that's 1, that's 1. And what did I just say it was? 2, negative 9, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's negative 9. There's 2, negative 9, and I know it opens upward. I do have a couple other points because I have the intercepts. 1, 2, 3, 4, 5. I have 0, negative 5 for my y-intercept. I have 2, 3, 4, 5. I have 5, 0 and negative 1, 0 for my x-intercepts. And like the last example, I could probably come up with something reasonable just from those 4 points. I'm going to make a t-chart all the same. Is this off? Nope, this is still on the screen. It should be x, y. 1, 2, 3, 4. So I'll put the vertex in the middle, which I just said was 2, negative 9. So 1 bigger, 1 smaller. 2 bigger, 2 smaller. Well, the 0 is easy because I know I got 0, negative 5. That's kind of nice. If I plug 1 in, 1 minus 2 is negative 1. Squared is 1. 1 minus 9 is negative 8. So these are negative 8s here. So let's see, I have 0, negative 5. I also have 4, 5. Negative 5, excuse me. And then I have 1, negative 8, and I have 3, negative 8. That's definitely enough points to come up with a curve, a reasonable sketch. Now, not only should you be able to, for this quiz, be able to sketch parabolas, but eventually I'm going to get there. We should also be able to graph higher order ones. But there's my 4 graphs. I knew that that was going to take some time. Okay, but I figure the more you see it, the more it'll stick with you. At least that's my hope. All right. Now, let's try something different with parabolas. Here, I have points. I have the vertex and a point on there. In fact, my point turns out to be the y-intercept. That's just coincidence. Okay. It says, find the quadratic function that has the indicated vertex and whose graph passes through the given point. Now, right off the bat, you have to have memorized to do this the standard form or the vertex form. A times the quantity x minus h quantity squared plus k. If you don't have that, you're sunk. Because there's your h and your k. So right off the bat, I have a times the quantity x minus negative 2 is x plus 2, and then plus 5. And this is your y value here. I'll just write a y for right now. And that's my answer, except for one thing. I don't know what a is. And I can't just put down a 1 and think, well, that's easy enough. I have to use the fact that they gave me an additional point, and I'm going to plug it in for x and y and solve for a. So now I have 9 equals a times 0 plus 2, quantity squared, plus 5. See, what I did is I put the point 0 in for x and 9 in for y, and now I'll solve for a. So I have 9 equals, this is 2 squared of 4a plus 5. I'll subtract 5 from both sides. I'm running out of space. Divide by 4. Oh, look at that. There's a quinky-dink. A actually is 1. So let's go back to here and write my function. F of x is equal to, now, if I put a 1 there, times the quantity x plus 2, quantity squared plus 5, I really don't need that 1. It's nice that I have it, but I don't need it. So I'll go ahead and just erase that. And here is my answer already in standard form. So you should be able to do this one. Very similar. All right, so I have same starting guy here. Okay, now I'll plug this in for h and k, so that gives me f of x is equal to a times x minus 2 quantity squared plus 3. And then I have the point 0, 2 in for the x and the y. All right, so 0 minus 2 is negative 2. Negative 2 squared is 4, so I have 2 equals 4a plus 3. Subtract 3. I have 4a equals negative 1. Divide by 4, I have a equals negative 1/4. So that goes right in there. So my answer is f of x equals negative 1/4 times the quantity x minus 2 quantity squared plus 3. Now that's only 2 examples, and I know I did 4 graphs, but I suspect there's going to be one of these on there. So if you need to, you go into the book and you find yourself another example, and make sure that you practice it so you feel comfortable with it. All right, now the last one, I just picked a simple story problem. You had some story problems in the assignment. This one's fairly simple. It says find 2 positive real numbers whose product is a maximum. And what do we know about these 2 real numbers? They add up. Their sum is 110. So if my 2 numbers are x and y, I know that x plus y is equal to 110. I want to maximize the product. I'm going to use capital P for product. So the product is going to be x times y. The product of the 2 numbers, positive numbers. So that's one too many variables. I need to either get rid of the x or the y. So this is my primary equation. This is what I'm trying to maximize. So I go to my secondary equation that already has x and y related, and I'll subtract x from both sides. I get y equals 110 minus x. Boom. So in for y, I'm going to replace it with 110 minus x. So I'm going to, in fact, call this p of x, because now everything's in terms of x. I'm going to distribute, and I get 110x minus x squared, which I'm going to rewrite as p of x is equal to the opposite of x squared plus 110x. Now, ladies and germs, because the parabola has the quadratic function has an a value that's negative, the parabola has a maximum point because it's inverted and the vertex is sitting on top of the hill, which means the y value, my product, p for product there, is going to be as big as any point on there, and that's what I'm trying to do, is I'm trying to find the maximum. Now, I haven't done an example. Do I have one where I show you how to complete the square? I don't know if I put one down like that. I'll show you how to complete the square here. To complete the square and put it into vertex form or standard form, because that's, I didn't do any examples, that's certainly going to be on there. You have to have a lead coefficient that's 1, and this isn't. This is a negative 1. So you factor out that negative 1. Factor out of the 2 terms that have the variable. If there's a third term here, if there's a plus 7, leave them alone. Just put the plus 7 on the end. So if I factor a negative 1 out of this, this gives me x squared minus 110x. So I have to take half of this number, which is negative 55, and then I have to square it. Now, I don't know what that one is, but I did remember to bring my calculator with me today. So let me clear that out. And that would be negative 55 raised to the second power, 3025, plus 3025. Now, if I add 3025, I really didn't add it because of the negative 1 right there. I subtracted it, so I'd have to add it on the end. See, I don't know if you want to do this or go with x equals the opposite of b over 2a, but I wanted to complete the square. So this is negative 1, or just the opposite of x. And this is 55. And this is a minus, because of the minus sign there, plus 3025. So I can see that my vertex is 55, 3025. So this is my x, and this is my y, which is my p of x. So see, if x is 55, then y is 110 minus 55. It's 55. So both of the numbers are the same. They're both 55, and the product, the maximum product, is 3,025. So it says find the two positive numbers. The two positive numbers are both 55. There's the answer to that one. Nice little story problem. Okay? Let's do one more completing the square. Before we go on, I'll just make one up here. F of x is equal to 2x squared minus 8x plus 4. Now, okay, let's say they ask for you to find the vertex by completing the square and putting this in, because they may ask for you just to rewrite it into standard form or vertex form. So you got to make it look like this. Right? So to do that, I have to complete the squares. So the first two terms that both have the variable, I'm going to factor out the 2 because my lead coefficient must be a 1. So if I factor out the 2, out of just the two terms with the variable, I get an x squared minus 4x. Now I'll leave a little space and I'll put a plus 4 on the end. So now I have to complete the square, take half of this number, which is negative 2, and square it. That'd be a positive 4. But I didn't really add 4. I added 2 times 4, or 8. So to balance that, I'll subtract 8 from the same side. 2, and then this is a quantity squared, and this is minus 4 on the end. This is an x. This is a 2 and a minus sign here. Now if that was a plus, then this would be a plus sign. So if they do ask for the vertex is 2, negative 4. 2, negative 4. Kind of the opposite of what it looks like inside, exactly what it looks like outside. And then I also know that it opens upward and I can do more stuff to it if I need. Okay. Practice that completing the square. I'll bet you a quarter there's a problem on your quiz where you have to change it from this form into this form, or, you know, for maybe not this exact problem, but something like it. Okay. Let me move this to the side. I know that this video is already longer than you want it to be, and I'm only halfway done with the problems, but I'm just trying to show you a little bit of everything here. Now these next 4 problems actually go pretty fast because you're using the leading coefficient test, which I talked to you about earlier with the leading coefficient test back here, about if the degree is even or odd and if the lead coefficient is positive or negative. It says use the leading coefficient test to determine the right hand and left hand behavior of the graphs, or sometimes they're called end behavior, of the graph of the polynomial function. Alright, so I look for the highest degree term in each one of these. There it is. This is the highest degree term. My degree is even. It's 2. And my lead coefficient is greater than 0. It's also 2. So this tells me that it rises to the right and to the left. Okay, now how did I know that? Well, I know that because I memorized the leading coefficient test. Also, I can kind of tell this is a parabola that opens upward, so it's going to rise to the right and to the left. This guy here, you can write it as the opposite of x to the 6 plus 1, so that your highest degree term is written first. It's in descending order, but you can see that this is also even degree because 6 is even, and in this case my coefficient in front is a negative 1, so my lead coefficient is less than 0. Well, if that's the case, instead of rising to the right and to the left, this thing falls to the right and left. Because of those 2 parts there, and you say, well, if he has a graphing calculator and he lets us use it, what if we were just to graph it? All right, well, let's graph this. This would be the opposite of x raised to the 6th power plus 1. So it would look like that, and if I graph this, you can see that it falls to the right and to the left. All right, next guy up. This guy here has odd degree. It's already in descending order. So odd degree. Okay, and my positive lead coefficient here is 2, greater than 0. So this is the one where it does different things on the ends. If one end's rising, the other end's falling, and so on. And because I have a positive lead coefficient, it rises to the right and falls to the left for a right-hand behavior and left-hand behavior. If it helps you, you can rewrite this one as negative 5x to the third plus 4x to the second minus 2x plus 6. You don't really need to, but if you like it, that's fine. So I also have odd degree, but this time I have a negative lead coefficient less than 0. So it's just the opposite of what I just did. It's going to fall to the right and rise to the left. Falls to the right and rises to the left. Now, again, let's use a calculator, you could graph it and see what happens, but that could get kind of messy and you might not have the right window, so you're better off just flat out memorizing this stuff. But I did 4 problems there in just a couple of minutes. That's not so bad. Now, in this next one, it says find the real zeros of the polynomial. This is degree 2, so it can have at most 2 real zeros. This one is degree 4, so it can have at most 4 real zeros. This one also can have at most, since degree is 2, 1 turning point, whereas this one could have as many as 3 turning points, n minus 1. So in this problem here, I'm going to set x squared plus 10x plus 25 equal to 0, just like I was finding x-intercepts. And this one actually factors to x plus 5 times x plus 5. And if I set x plus 5 equal to 0, I'd be doing it twice. If I went ahead and set both factors equal to 0, I'm going to get negative 5. I'm just going to get it twice. So my 0 is negative 5, but since I get it twice, in parentheses I'm going to write multiplicity 2. So that counts as the 2 zeros, the 2 real zeros. Next guy up. This one again, if you're lucky, it'll factor, so you don't have to trial and error or have to use a calculator to work it. And this one does factor. If I said x to the fourth minus x to the third minus 20x squared equal to 0, I can factor out an x squared, a GCF. And what's left factors further. So that's x squared times, this is going to be x minus 5 times x plus 4. So it looks like I'm only going to get 3 zeros. This one and this one and this one are going to give me zeros, but I have this factor twice. So I'm going to get 0 twice here, multiplicity 2, and then I'm going to set x minus 5 equal to 0 and x plus 4 equal to 0. So I get x equals 5, and here I get x equals negative 4. So my zeros, I can squeeze all this in here, would be 5, negative 4, and 0, multiplicity, I'll abbreviate, 2. Now, I don't know if he's going to want you to write out multiplicity 2. I would probably think that that was a good thing, but that's how you work it. Now, we're going to get to the graphs, but again, before we get to the graphs, what if they give us information and they want us to find a polynomial function that has this particular information? Well, in problem number 17, it gives you 2 zeros. And remember, the number of real zeros is the greatest degree. This is going to be degree 2. So this is going to be a polynomial of degree 2. It's quadratic. So here's the suggestion. Just write it as 2 binomial factors. All right, so that I would get negative 4 and 5 as the answer. Well, to get 5, it would be x minus 5. To get negative 4, it would be x plus 4. So this is going to be x squared minus x minus 20. There's my function. I could also multiply through by 2 or 3 or 4, and because it says find a polynomial function. Now, if they gave us another point, then we'd have to put the a out in front and go through the process. I did that earlier. Now, you say, didn't you show me a little trick on what to do with quadratics if I know the 2 roots? Absolutely I did. F of x equals x squared minus the sum of the roots of the zeros, x, plus the product. Okay, so what's the sum? Well, negative 4 and positive 5, if you add those together, that's 1. So I get minus 1x, or just minus x. And if I take the product, negative 4 times positive 5 is negative 20, so plus negative 20 or minus 20. I get the same thing. I like that a little bit better, especially when it gets messy. But that's a good trick to remember, and it's not going to probably be in your book. That's a good one to memorize. All right, now in this next one, I'm going to have f of x, and if I write it out the long way, I'll have x minus 4 from the 4. I would have x minus the 2 plus square roots of 7, and x minus the 2 minus square roots of 7. Note the parentheses inside because you're subtracting like a binomial effect there. You have two terms. Now I'm not multiplying this out. This would take me forever. I'd have to first distribute by the negative and then a trinomial times a trinomial, get that, and then multiply it by a binomial here. But I can use the number trick here. Okay, so this is f of x is equal to x minus 4. Now this is going to give me x squared minus the sum. What do I get if I add those together? Well, if I add 2 plus the square root of 7 and 2 minus the square root of 7, the square root of 7's cancel, I get 4. So that's going to be minus 4x. Now what's the product? Well, that's a little bit more of a pain. I'd have to take the 2 plus the square root of 7 and multiply it times the 2 minus the square root of 7. That's the product. And that's like conjugates kind of an effect here. So that's going to give me 4 minus 7, or negative 3. So this is going to be plus negative 3, or just minus 3. Now it's not so bad. I have a binomial times a trinomial. I can live with that. If I multiply 2 by x, I get x to the third minus 4x squared minus 3x. If I multiply by a minus 4, I get minus 4x squared plus 16x plus 12. So my function f of x is equal to x to the third. I have a minus 4x squared and a minus 4x squared. That's minus 8x squared. I have a minus 3x and a plus 16x. So that's plus 13x. And then I have a plus 12. Yikes. That's one way you could do it. Again, that's probably messier than what you'd see. I can imagine something like this, though. And be careful. If one of the roots is 0, for example, if they said, for instead of negative 4 and 5, let's say they'd said 0 and 5, then this would have been x minus 0 times x minus 5. And of course, x minus 0, that's just x. And that's even easier. There you go. So be careful on those. All right? Now, let's do a couple graphs. And we'll end this very long video that you're probably more than just a little bit tired of. Okay. I would think he would have a graph on there. I have some graph paper with me here. And I would bring graph paper with me to school unless you're sure that he's going to supply some. All right, this is a cubic. It's like a sideway S. Odd degree, positive lead coefficient means as it's going to rise to the right, but it's going to fall to the left. Okay, so I just make a little picture of it in my head. I got to find my x-intercepts, so I'm going to take x to the third minus 9x equals 0, because you're going to have to plot some points. Now this factors to x times the quantity x squared minus 9, very convenient, which is x times the quantity x minus 3 times the quantity x plus 3. When I factor, it's a difference of squares. And I get 3 zeros here. I get 3 x-intercepts. I get 0, which is going to be 0, 0, the origin. I get 3, which is going to be 3, 0. And I get negative 3. So on my graph, let me grab some graph paper here. It's got torn a little bit. Let's see. So this is 1 here and 1 here. So I have 3 points already. I have 0, 0, I have 3, 0, and I have 1, 2, 3, negative 3, 0. Now I know it rises to the right and falls to the left, and it's degree 3. So that means it could have 2 turning points. I bet it looks like a sideway S like this. I bet it's symmetric to the origin as well. But to make sure and get some points, and be careful with your calculations because you'll be in a hurry, pick some points to the left and to the right of these intercepts here. Like I would have negative 4, negative 2, negative 1, 1 and 2 and positive 4. And plug them in. It's a pain, but plug them in. So negative 4 cubed is negative 64. Minus 9 times negative 4 would be plus 36. Negative 60, that's 28. This is 28. Plug negative 2 in, that'd be negative 8 plus 18. That'd be 10. Plug negative 1, 10 or negative 10? Oh, negative 6, this is negative 28. I thought that didn't look right. Sorry about that, that's a negative 28, excuse me. Plug negative 1 in, that'd be negative 1 plus, that'd be a positive 8. Plug 1 in, 1 minus 9, it'd be negative 8. And these are just going to be the opposites, I bet you. It'd be 8 minus 18, it's negative 10. And 64 minus 36 is positive 28. Now, those numbers are a little bit off my scale, but that just tells me how steep it is. I am going to graph the other points. 2, 3, 4, 5, 6, 7, 8, 9, 10 right there. So I have negative 2, 10, negative 1, 8, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. I have 1 negative 8 and 2 negative 8 and 2 positive 10. So there's my elongated S. So best I can try to make it, and this is going to be very steep. This is going to come down. Now it might peak up here, I don't know. I don't know if this is a maximum. It's kind of sloppy. Sorry about that. Take your time. Do a better job than I'm doing. And there's my sketch. And it's an elongated kind of sideways S there. I hope that you can see all that. I needed that table to get those extra points. One more. Okay, this is degree 4, and it's got a positive lead coefficient. So that tells me it's going to open to the right and to the rise to the right, and it's going to rise to the left. That helps there. And let's set 3x to the 4th minus 48x to the 2nd equal to 0. I can factor out a 3x squared. It gives me x squared minus 16. Oh, that's nice. Now the difference of squares, that's x minus 4 times x plus 4. So I've got a double rooted 0 here. So my x-intercepts, I'm going to have 0. I'm going to have 4 and negative 4 for my zeros of my function, but my x-intercepts are going to be 0, 0, 4, 0, and negative 4, 0. Now, when you have degree 4, sometimes it looks like an M, sometimes it looks like a W. Since it's going up, I'm thinking it's going to look like a W. Something like that. I'll need to plot some points. All right, let's see. I have at least one more sheet of graph. Oh, I do. Saved by the bell. One more sheet of graph paper here. Let's bring this over. Okay, so I'll figure out my scale here in just a second. I know what my scale is going to be on the, yeah, I think it's probably going to look like this. Okay, I think I know anyway. It's going to, here's 1. So I'm going to have 0, 0. I'm going to have 2, 3, 4, and 1, 2, 3, negative 4, 0. So I'm going to make a T-chart. So let's see, negative 5 would be smaller than probably negative 3, negative 2, negative 1, 1, 2, 3, and then 5. Okay, now I know that's a lot. If you don't have time, do a couple on each side here. If I plug negative 5 in, this is going to be a mess. I almost rather plug it into this form of it because it's already factored. Negative 5, that would be 75 times negative 9 times negative 1. That's going to be a big old, that's going to be big. Bigger than I'm going to mess with. If I plug negative 3 in, negative 3 squared is 9, so that's 27 times negative 1. That's negative 27 times 7. Got to get my calculator out here. Make sure you bring your calculator with. Negative 27 times 7 Yikes, negative 169. This is a stupid problem for me to do. All right, negative 2, that would be a positive 12. That'd be a negative 6. Times 2 is a negative 12. That's negative 144. If I plug in negative 1, that'd be 3 times negative 5 is negative 15 times 3 is negative 45. Yikes. If I plug in 1, that's 3. Oh, look at this. Is it negative 45 again? I think this is negative 45 again. So I definitely have some symmetry here. Now I wouldn't know that until I actually plug the numbers in, but so what I'm going to have to do, since these numbers are so big, is I'm going to have to make each one of these worth 20. So negative 5, it's way up here. It's coming down fast. It hits this point, and then at negative 3, 1, 2, 3, 4, 5, 6, 7, 8. There's negative 160. It'd be about negative 168. About there. Negative 2, negative 144 would be about there. Negative 45, it would be about there. So my graph is coming down steep. And then it comes up to the 0. Now it doesn't cross. You see how it goes back down? It curves. Here's my W shape. What a bear this one is. Sorry about that. I picked one out of the book, but I guess I should have made the key up sooner. So this is going to go up like that. This is quite a graph there, but that's my graph that goes with. I would suggest that you practice graphs. Try some of the first ones that they ask you to graph, especially the odd ones, so you can check your answers in the back or check your answers on your calculator. But definitely bring a calculator with you when you do these. Now, I don't know if I covered every single thing, but I covered a bunch of things. And unfortunately, this video is probably over 40 minutes long, so it might take you a while to get all the way through it. In fact, it might even be pushing 55 minutes here looking at my watch. So you try these problems, you ask questions if you're unsure. I don't mind you give me a call. Practice, practice, practice.